So we're going to revisit again the number of protons, neutrons, and electrons in an atom and in its ion form. So if you had an element, let's say the element had a weighted atomic average for its mass of, let's not do that one. Let's say the element 87.62. Okay. You look on the periodic table for 87.62 and you see that that's strontium, and strontium has an atomic number of 38. Okay. So in the atom form, that's the neutral form, let's take a look at the subatomic particles. So the protons in the nucleus, which are positively charged, are equal to the atomic number, so that's 38. The electrons, which are negatively charged, in this case, the protons minus the electrons need to give a 0 net charge, so the electrons have to be 38. Okay. Now the trick here is what is going on with the neutrons. Okay. So we know here that this atomic mass is the protons plus the neutrons. So we know that there are 38 protons. Well, how many neutrons are there? Well, the number of neutrons can change, but on average, we'll say that there's 88. So if we take 88 minus 38, okay, that is going to be 50. So the neutrons in this case would be 50. Now, what about the ion? Okay, the only thing that's going to change out of the ion is the electrons. If the protons change, it is not strontium anymore. The neutrons can change, but the neutrons are neutral, so it would not affect the charge of the ion. So if we looked at the ion, we'll go ahead and just do that down here. In this case, we're talking about a cation ion. Let's go through and label it out. The protons are going to be equal to 38. The neutrons, in this case, say are 50. And the electrons, well, who does strontium want to be like? Its nearest noble gas is 36. So if we're looking at the charge here, that's going to be a charge of +2. So again, very simple. The number of electrons are always going to match the atomic number of a noble gas. In this case, that noble gas is krypton. And some really interesting things happen when you look at elements such as silicon. So let's look at silicon on the periodic table. So silicon has an atomic number of 14 and an atomic mass of 28.0855. Okay, so the deal is, who is silicon's nearest noble gas? Well, we have neon, which is 10, and then we have argon, which is 18. So it can either lose 4 and become silicon +4, or gain 4 and become silicon -4. So silicon has some flexibility here, and that kind of lends insights into why silicon-based organisms are common in science fiction, given that we are a carbon-based organism. So hopefully this just gave you a little bit of an extra review. Last thing when you're doing the problem, things form charge because they gain or lose electrons. But who are they gaining or losing those electrons to? Not just thin air. So when you get to the question about why lithium and fluorine make a good pair, I want you thinking about their relative charges. And really, where do you think those electrons are going?